Howdy, 7th grade. Today we're going to be talking about how to do some operations while we're using scientific notation instead of standard notation. So to start off, we're going to talk about what exactly scientific notation is. We've talked about it a couple times before, but just kind of as review. Scientific notation is a different way to write numbers, normally if the numbers are really big or really small. So one of my favorite numbers is the speed of light, and what that is 300 million meters every second is how fast light goes. And how I would be able to write this in scientific notation, because that many zeros is kind of a pain to write out, is I would just write 3.0 times 10 to the power of 8 meters per second. And how I got this is I just moved my decimal, so I only had one number to the left of it. So my decimal started here, and I moved it 1, 2, 3, 4, 5, 6, 7, 8 times over to here. So that gives me 3.0. Then I multiplied it by 10 to the power of 8. And the 8 comes from how far over I moved that decimal. Because I moved it over 8 spaces, it's 3.0 times 10 to the 8. Another example would be if I had 1200, I would take my decimal and move it over 3 times, and I would end up with 1.2 times 10 to the power of 3 because I moved it 3 times. And one more example just for good measure, if I have 0.0025, I only want one number to the left, so I'd actually move this to the right 1, 2, 3 times. That gives me 2.5. Because I moved it the wrong way, this is going to be negative, so it's times 10 to the negative 3. And that's how I would write this standard number in scientific notation. So those two numbers are the same. So getting into some operations with this, I want to make note that we're going to be doing this kind of separately. What that means is we're going to deal with the scientific notation numbers separately from the regular numbers, and that's going to make our life a lot easier. So an example would be 1 times 10 to the negative 2. Let me get a new color for this. 1 times 10 to the negative 2. We're going to multiply that by 2.5 times 10 to the power of 3. And like I said before, we're going to look at these separately. So I'm going to separate this out, and I've got my regular numbers right here, and my powers of 10 right here. So I'm going to start with the regular numbers, and I have 1 times 2.5. And 1 times 2.5 I really hope is 2.5. Then I'm going to look at the other side, and I have 10 to the power of negative 2 times 10 to the power of 3. And when I do that, if we remember when we multiply exponents, that means that we just add the exponent. So this is going to be 10 to the negative 2 times 10 to the power of 3. We're going to add 3 and negative 2. So that gives me 10 to the 3 plus negative 2. 3 plus negative 2 is the same as 3 minus 2, so that is 10 to the power of negative 1. And my final answer is going to be 2.5 times 10 to the power of negative 1. So all I did here was I took my problem, I split it up into the normal numbers on one side, the exponentials on the other. I solve them separately, and I multiply them together at the end. And that's something we can do anytime we have scientific notation and we're multiplying or dividing with them. Speaking of dividing, I would very much enjoy working on the problem. Let me write this out. It's 2.4 times 10 to the negative 8, and we're going to divide that by 2 times 10 to the negative 2. Once more, the first thing I'm going to do, the first step is going to be to separate them. So separating them means I take my 2.4 and my 2, and I write it on one side. 2.4 divided by 2. And then I'm going to take my 10 to the negative 8 and 10 to the negative 2 on the other. And after that, I'm going to solve these separately. So 2.4 divided by 2 should be 1.2. and 10 to the 8 divided by 10 to the negative, 10 to the negative 8 divided by 10 to the negative 2. When we multiply, we add these, so when we divide, we subtract. It would be 10 to the negative 8 minus negative 2. Minus a negative is the same as adding a positive. So you have negative 8 plus 2, which is going to be 10 to the power of negative 6. So my final answer is going to be 1.2 times 10 to the negative 6. And just like that, we are finished. And basically all these problems are going to be repetitions of separating. Second step is solving separately. And my third step of putting it back together or reassembling it. And after that, we will get the final answer every time. Kind of a little bit more review, just to make sure we have this in our notes, I want to reiterate one more time how multiplying and dividing exponents work. So if I have 10 to the 3 times 10 to the 5, that's going to give me 10 to the 3 plus 5, and 10 to the 3 divided by 10 to the 5 would be 10 to the 3 minus 5. And that's how our multiplication division is going to work for all these problems, which is going to simplify how we work with these powers of 10 a whole lot and make our lives a little bit easier. And that'll let us hopefully work within scientific notation a little bit so that we can deal with bigger numbers without having to deal with all those zeros, because that is a pain. In any case, I will see you guys in class, and we'll work on this a little bit together there. Toodaloo.